Welcome to Lecture 9. At the end of this lecture, you should be able to design class diagrams for a given problem and use them for object-oriented program implementation. So in the previous lecture, we were given two case studies. So what did we do there? We just read the given description and we directly went and wrote the code for it. However, when you are developing a large software system, we can't do that. When we are given a problem, we just don't go and write the code for it. Before actually doing this implementation, we have to analyze the given problem and we have to design our software system. In order to understand the importance of designing, think of how we build a large building. So when you want to build, let's say, a hospital or a hotel or maybe an apartment complex, do we just go and start building that structure? No. So what do? We get a professional architect and he will design the building. So, and then after that, there will be structural diagrams and electric diagrams. Likewise, there will be many different diagrams developed. So, there will be a lot of communication going back and forth between the client and the engineers and the architect to finalize the design of this building. The same happens in software development. When we are building a very complex, large software, there's a lot of communication going back and forth between the clients and the software engineers, software architects, and business analysts likewise. So before building the system, they all get together and design this system. So when designing the system, what they do is they develop different ways and different models that explain this system. So just like when we build a house where we create architectural diagrams and structural diagrams, in software development also during the design phase, we develop different design diagrams. So in this lecture, we will be learning how to develop such one design diagram, which we call the class diagram. In the class diagram, what we are going to specify is what the system must do, but not how the system will do it. So when we actually use the class diagram to implement the system, we are essentially transitioning from the what aspect to the how aspect. So in the class diagram, we will be mentioning the classes that will be there in our system and the fields and the methods that each class will have, and also the different interactions that will be there between these classes. So keep in mind, when we are developing class diagrams, it is not the only diagram that we can develop to describe our system. So there are many different diagrams such as use case diagrams, sequence diagrams, active diagrams that describe different aspects of our software system. So collectively, these diagrams, how we can develop them is guided by the Unified Modeling Language or UML. So in this lecture, we will be looking at only the UML class diagram. So in essence, a class diagram is a picture of the classes that will be there in our system. We can also show the fields and the methods that are there in the classes and the relationships or connections that are there between the classes. However, we are not going to show how exactly the classes are going to interact with each other during runtime, and we are not also going to show the algorithmic details. That means how the methods are actually implemented. We just mentioned these are the methods that are going to be there in a given particular class. So the basic building block of a class diagram is the class. So it is drawn as a rectangular block, and we divide it into three compartments. The top one is the class name, middle one is the attribute, and the bottom one is the operations, that means the methods. So let's first look at the top compartment. So this is very simple. You just draw a rectangle and then divide it into three, and the very top compartment you write the class name. Next we have the attributes. So in the middle compartment we can specify the attributes. So here's a a descriptive way of putting attributes. So as you can see, we have the at the very beginning we have the visibility type, and then the name of the attribute, and the semicolon, and the type of the attribute. And if you want, optionally you can put the default value as well. So here we have shown again a descriptive view of the how we can specify the attributes. Especially if you look at the accessibility types, the plus means the public, just like what we learned for the Java programming. Plus means public, and hash means protected. That means in a superclass you can specify protected members. So this also in this notation also we can show that. And then minus means private, and this slash sign shows a derived attribute. So derived attribute means the actual attribute is defined in the superclass, and the subclass is just using it without having to define it. And if you don't put any accessibility modifier in front, that means just like what we saw in Java, that means no access modifier. And finally, the third compartment, we have the method details. So method also, we can show the accessibility type, the name, the list of parameters, and for each parameter you can put the name for the parameter and the type. And then finally, if the method has a return type, you can give the return type as well. So the most descriptive way to draw a class is what we show here in the rightmost side, where you get the rectangular block and divide it into 3 compartments. On the very top we have the class name, middle we have the attribute set, and then in the bottom compartment we have the set of methods. However, when you have a lot of classes, it will be very cumbersome, and your diagram will be very cluttered if you are going to include all the attributes and methods of all the classes. So in such a case, you can use any of the other notations. So the most simplest one, the less informative one, is what we see here in the top left, where you just show the name of the class. So any other way is also possible. It is according to your need. So once we have identified the classes, the next step is to identify the relationships or the interactions that exist between the classes. So in Unified Modeling Language class diagrams, we identify 4 different types of relationships between classes: dependency, generalization, association, and realization. Out of these, you already know generalization relationship. It is nothing other than the superclass subclass relationship. So here we have shown the notation. We have a triangular arrowhead pointing towards the superclass, and the arrow is originating from the subclass. So the arrow is going from the subclass to the superclass, and the arrowhead is a blank triangle. So this is none other than the subclass superclass relationship. And if you are given this diagram, you know how to write the code for this diagram. That means we have the public class person and public class student extends person. The next relationship is also very familiar to you. This is the realization relationship, and this refers to a class implementing an interface. So here we have the student class that implements the iPerson interface. Now here, as you can see, we explicitly identified that this is an interface by putting this word interface between these 2 marks. So here this is called a stereotype. So the notation is the arrow going from the implementing class towards the interface, and the arrowhead is a blank triangle. And if you see the arrow line, it has to be a dotted line. So this is what differentiates the notation of realization from the notation of generalization. So if you are given a diagram like this, now you know how to write the code for this. So we have the public interface iPerson, and we have public class student implements iPerson. Now this is a new relationship that you have not come across earlier. So now think of a relationship that will be there let's say in a school between the student and an instructor, or maybe in the university, the relationship between the student and the instructor. So we can say student learns from the instructor. On the other hand, we can say instructor teaches student. So the relationship we saw earlier, the realization relationship and the generalization relationship. What is that relationship? If you remember what we learned earlier, this is a relationship. The student is a person. And similarly, a student is an I person. However, what can we say here? Can we say that student is an instructor? Or an instructor is a student? No. So that this relationship is different from what we learned in the previous two slides. So this relationship is called association. In other words, we can say there is an association between the student class and the instructor class. And so this is the basic notation we can use. If you want, you can add some additional information. This is multiplicity, the name of the relationship, class rows, and the navigability. Let's see what they are. So as you can see, now we have added some number and two dots and an asterisk. So this is how we show the multiplicity. This shows how many objects from one class is associated with an object in the other class. For example, this we read as a student has one or more instructors. So when we say student has one or more instructors, the number comes near the instructor class. And on the other hand, if we have some number near the student, we can say an instructor teaches some number of students. So this multiplicity value can take different forms. For example, some we have shown here. So the first one, if you just put the asterisk, this means the class 1 can have one or more objects from the other class. So next one is, if you just put a number like 1 or 2, it's exactly that number. Or else we can give a range. For example, here 2 to 4, the relationship. For example, if we use the same example, we can say a student can have minimum 2 and maximum 4 instructors. That means 2 and 4 are inclusive. And another form is a number and 2 dots and the asterisk. And if we apply it here, we can say a student has 3 or more instructors. So likewise, you can have different variations in this multiplicity number based on your requirement of the given problem. And if you want, you can have names for the association and the roles that are played by the objects in this association. For example, we can read this as instructor teaches student. And to the other side, we can read student learns from instructor. So if we try to incorporate the multiplicity information as well, we can read as instructor teaches one or more student, and a student learns from one or more instructor. And if you want, you can give a name to the association as well. And this naming is useful when you create method. For example, now in the instructor class, we can have a method name as teach. And similarly, a student may have a method name learn. So if you are having methods like that, it's good to have some, correspondence between the name you use in the your code and the name you use in the class diagram. Otherwise, when you try to compare your class diagram with the code you have written, it will be confusing. The same goes for the class name. So if you have certain names in your class diagram, make sure you use the same names when you implement this class in your code. And sometimes there can be dual associations. That means the certain objects play different roles with respect to the same object. For example, in this case, a student is a member of a team, and some of these students, one or two students, or maybe one student, will be the president of the team. So in this, if you read the relationship, we can say a student is a member of one or more teams, and a team has one or more students. So that means a team can be created only if there's at least one student. And on the other hand, we can say a student must be a member of at least one team. And if you read the bottom relationship, we can say student is can be member of one or more teams, and team has exactly one student as its president. And how are we going to implement this relationship? Now we learned how to implement the generalization relationship as well as the realization relationship. How are we going to implement the association relationship? In order to properly implement the association relationship, we need to have an idea of the navigability of the association as well. So as you can see in this bottom diagram, now we have an, instead of just a line, now there's an arrow going from router to the domain name server. This means the router can navigate to the domain name server, but not the other way around. So sometimes you can have the arrowhead to the other side as well. When you have two arrowheads, you can simply remove the two arrowheads. In other words, if you have just a plain line, it means there's two-way navigability. That means student can navigate to team and team can navigate to student. So if there's no such two-way navigability, it is always advisable that you actually indicate the navigability direction. So what do you actually mean by this navigability? So let's look at this example. Suppose there is a navigability from the team to the student. So that means the team can access the student object but not the other way around. In other words, the student cannot access the team object. Now see here. So inside the public class team, we have a variable of type student class. That means the team will have a student object. That means the team can access the external interface of the student. That means the team can call the public methods of this student object. However, in your student class here, we don't have any reference to the team object. That means student does not have navigability to the team. So this shows one-way navigability from the team class to the student class. So if you want to have two-way navigability, that means team can access the student object and the student can access the team object. So then how can we implement this? So when we create a student object, it should have a parameter to take a team object, and then the current team object using the keyword self, we can pass it to the student object. So that means in that way we can have two-way navigability. So in certain cases, we have many-to-many relationship. So here if you read, a student can take one or more courses and the course can have one or more students. Now, if you want to record information that is specific to a student and a course, a pair, right? Student course pair, where would you put it? Would you put it to the student class or would you put it to the course class? So in such cases, since it is difficult to decide where to put, what we do is we add an additional class. So which we call a link class or an associative class, because this class is connected not to any other class but to the link between two classes. So during the implementation, there is no hard and fast rule as far as I know. If you want, you can have a, for example, if we focus on this given scenario, you can have a separate course enrollment path. If not, you can have maybe hash map kind of data structure either in the student or the course, or maybe in both, to get this behavior implemented. So here's another special case of the association relationship, which we call a self-association. So self-association is denoted by a link that goes from the class to the class itself. So this is a very common scenario you find when you implement the linked list in data structures. So if you want to implement a self-association, what would you do? So this means inside the linked list node class, it has a reference to itself. That means we are having an object reference of the same type linked list node. And here's another special type of association, which we call the aggregation. Now, if you look at the previous relationship that we looked at. So student takes a course and the course is taken by a student, right? So there's no such thing as student has a course or course is made out of students. So in contrast, in certain cases, we can say one object is made out of some other objects. So in other words, we can say a whole object is made out of a set of part objects, which we call a whole part relationship. So for example, if you take a car, it is made out of an engine and a transmission system and set of wheels. Likewise, however, we don't say here a student is made with the course or course is made with the student. So in other words, this is not a whole part relationship between student and course. In contrast, here in this kind of scenarios, we have a whole part relationship. So this is a special case of association, which we call the aggregation, where the car is the whole and the engine and transmission are considered as parts. However, at the implementation level, there is no difference between the how you implement an aggregation and how you implement the normal association that we learned earlier. So for example, here we have the whole class, the car, and it has a reference to the engine, where engine is a separate class. Again, the aggregation can have another variation which we call the composition. The difference between aggregation and composition is in the composition, when the whole dies, the part is also destroyed. In contrast, in the aggregation, although the whole dies, the parts can remain. So what does that mean? In order to understand, let's look at the code. So here we have the whole class, that means the car class, and when we are assigning or when we are creating the part, the engine object, the reference, object reference comes from the outside. So even if this car object that we create is destroyed, this engine object that came from outside will remain. In contrast, if you look at this example, here we have our whole class as the window. So it has reference to a menu object. However, from where do we get a reference to this menu variable? So in contrast to the previous example here, we are not getting the object reference to the menu from outside, but instead we are creating the menu object here itself. So what does that mean? When this corresponding window object is destroyed, the menu object that we created within its constructor also gets destroyed. So this is the main implementation difference between the aggregation and composition. Finally, we have the dependency relationship. So dependency relationship is a weaker form of association. So similar to the association, we mark the dependency relationship with the navigability sign. That means we have to put an arrowhead. So this means the course schedule has a dependency navigability to the course class. So what does this dependency mean? So that means the course schedule class has navigability to the course class, but within a limited range. So if you look at this example, what this means will be more clear. So here we have the course class, and then here we have the course schedule class. So inside the course schedule class, we have the method, and the course is taken as a parameter to the method. And then we have the B method, and inside the B method, we create an object reference of type course. Now, if you look at the objects we have here, so this C reference that comes to the method, and this new course object that we create inside the B method will have the local scope. That means these variables are accessed only within this method. So this C variable that corresponds to a course object will be accessed only within the method, and similarly this new course object will be accessed only within the B method. So although the class course schedule has a reference to the course object, this reference is restricted to method. So in that case, we say the relationship between the course schedule and the course is a weak relationship, which we call it the dependency relationship. However, if there is another place inside the course schedule where there is a a class level reference to the course class, that means there's an object of course class at the class level of the course schedule, then there is an association relationship as well. So if there is an association relationship as well, then you don't have to explicitly show the dependency relationship, because the association relationship can be considered to cover the dependency relationship as well. To summarize, in this lecture, we looked at how to design our software program with the use of a class diagram. And in a class diagram, we learned how to create or depict classes and to depict the relationship that exists between the classes. So in the next week, we will be starting a very new module, that means concurrency. Thank you very much.